I think they're just trying to make money off the Amiga nostalgia. So they kind of have a standardized form factor. I mean, it's interesting toy, but yeah, but at least you have a sensible machine. So now I've completely lost my train of thought. Not that I had much of one before. Yeah, my approach to that is basically using an using an FPGA dev board as a serial to Ethernet converter. But yeah, it's not a good idea. The last time I did something like this was I just took a piece of plyboard and lasered the required mounting holes in it, and that worked perfectly. But with the I mean, for the RISC-V I have the. Oh, it's done. That's interesting. The Intel took longer than the PowerPC to compile LLVM. That makes no sense. Oh, most of that was system time. Okay, so it was swapping itself to death. Okay, no further questions. Here for the tests it briefly went to a sensible amount of threads. I still haven't upgraded to anything. So basically what I have is a standard Debian bookworm and the official Star 5 kernel, because I have not gotten around to upgrading the kernel yet. But the closer you can get to basically running standard Debian on it, I mean, I have all of this here, and but it's still it's still missing a lot of stuff. But I'm trying to get to a state where I can use the or where I can use it as a normal Debian machine at least. And then I'm going to take a look at all the extra special things. I mean, the video encoding stuff is also going to be really, really wonky because they implement OpenMax only, and OpenMax has not been maintained since 2011, and the only thing, the only people actually touching it are Google, and Google are only upgrading it for Android, and it's a complete mess. Yeah, also they need to fix their bootloader. We are not... Basically, if you need to pass a DTB to your kernel, then your bootloader is shit and you should not be selling hardware. Especially on RISC-V. Especially on RISC-V, where yeah, you showed me that one already. Especially on RISC-V, where you have this nice three-stage boot process, where you have a stage 1 that determines that enables the memory, calibrates it, determines how much it is, and then passes a flat device tree to the OpenSPI stuff, with the memory nodes filled out. Why would I ever need to create a DTB with memory nodes in it to and put that on my EFI partition, which I'm not even using as an EFI partition, just so they can ship a broken U-boot that doesn't hand over the DTB it got. It's complete bullshit. And it's one of the things I don't want to fix, because if I make a habit out of fixing things other people broke, Debian mainline will not sort that out. It will just refuse to boot if their bootloader is shit, and then people will complain, and then they will say, yeah, but we should totally ship the DTBs. And then the systemd people the systemd people are like, we are the best friends of the embedded hardware developers because we have this great DTB manager. You're not supposed to have a DTB manager. It's working around the broken design. I have no idea how it's going to work. I'm just saying, nobody should ever communicate DTBs around so the kernel should receive a DTB or a proper device tree even from the bootloader, and it should use that. So as simple as that. Anyone who saves a DTB in a file is wrong. Anyone who loads a DTB from a file is wrong. Systemd people making it easier to load DTBs from files are especially wrong. I have no idea how the Raspberry Pi does it. Honestly, I have no idea. The last Raspi I've used was Raspi 1, and I was not happy about the way that worked, and it's wrong on a lot of ARM devices, yes. And people could do a lot better. people could build proper devices. No, I'm not touching anything that's not that doesn't come with a proper bootloader these days. I mean, when we build hardware, we manage to build proper hardware that boots without that boots a stock kernel and does not require any hacks. I hate user experience stuff. I hate doing this. Is there some code somewhere? Divert doesn't have any sensible options. This one maybe. No. No. The formatting here is also wrong. Okay, great. Okay, again. The thing is, the world is full of small bullshit hardware that is not properly supported, and it has been like this for 20 years. And everyone is saying, "Oh, we need to do our own Linux distribution that boots on our hardware and without any weird hacks, because we put all the weird hacks into our bootloader." Okay, now we can. So, das sieht nach einem Interface aus, das man möglicherweise unterstützen kann. Der ist also Skip. Was gab's noch? Resolve, Expand, Verbose, okay. Ja, gut, ich meine, das hier sind jetzt irgendwie 30 Commits und ich erwarte, dass jeder davon zerpflückt wird. So, wo sind denn die Option-Händler? Okay, set administered routes sind aus der Library, set no pager, dann setze ich mich doch da daneben. Set no pager. Was? Okay, es gibt ein Bad Usage. Okay, das ist gut. Ah, ich kann die einfach als Booleans behandeln und dann hinterher auflösen. Moin Smash! Das gefällt mir deutlich besser als... Ah, nee, das funktioniert so nicht. Ah, das ist lästig. Aber gut. Westcons, das ist immer noch total ungewöhnt zu tippen. Basically, so, history lesson. So basically what ARM did was that you had a machine number. You would allocate it from the ARM maintainers in the Linux kernel, and you would pass this number in one of the registers at boot, and then the kernel would look up the number and use the list of platform devices associated with your number as the initial device tree. So basically, the device tree only communicates your platform devices, anything you cannot discover. So yeah, and then they found that this was bullshit, which only took like 600 entries in the database to find out that it was bullshit. And then they went into how do other people do it? Oh, we can. Some of the people are using device trees, like a proper open firmware style device trees. Yeah, but handing over a device tree is annoying because you have to define an interface that the kernel can call in the firmware to get a device tree, then to get the root node, and then enumerate all the child nodes, enumerate all the properties on the device tree, and so on. So this is basically the proper open firmware. The kernel will read the entire device tree by scanning it. And then the ARM people said, okay, we could just serialize the entire tree and pass it over. And that's what they did. And none of these people ever learned how to write a proper device tree, and it shows. The thing is, device trees have vendor names in them. So if you define a device, then you are supposed to use your own name and a comma and a product name as the device name, and then a list of devices that your device is compatible with, which is most likely the name of the vendor that built the chips you are using, comma, their product number. So if I use a particular ADC and it's the core component of my system, and there's really not much else there, and it's connected to SPI, then I'm just going to say, okay, this is my device, and it's compatible with this ADC connected to this SPI bus, and you would essentially describe the entire static connectivity on your mainboard this way, which is a complete pain in the ass to do, but it's a lot better than actually defining it in a C file and then getting that C file merged. And x86 are not doing it any better. They are just doing it differently. So what they are doing is that instead of a device tree, they give you code for a virtual machine, and you run this code in a virtual machine, and then it builds a device tree for you. And it was so horribly broken that we had a device registry where people would upload alternative implementations so they could boot Linux. And yeah, by now, after like 25-ish years, they have finally managed to get to a point where it roughly works. I mean, I still have demessage errors about broken VM code, but at least it somehow works. And yeah, the ARM people are like, oh, gotta boot fast. So handing over a device to the traditional way would take way too long. And yeah, the thing is, do I have a good example of that? I mean, I could ask. Not sure if how easy it is to navigate this one. Ich bin immer noch bei User Merge, aber ich rente auch gerade über Device Trees, weil